Hello and welcome to this video for Chemistry 20, the gases unit. This lesson is going to learn the ideal gas law, okay? Now, the ideal gas law is the only formula that we do in gases that deals with the amount of gas that we have. Remember, volume is not amount. Volume is the space the particles are moving around in, okay? And yes, the amount is going to affect the volume, right? The more moles of gas you have, the more volume it will want to take up, okay? But the amount is actually the moles. That's the standard measure of amount of something in chemistry. N is moles, okay? But the question could also give you the mass. Remember how to convert from mass into moles. Your formula is to take the mass in grams and divide by the molar mass using your periodic table, adding the elements together to get the molar mass, which is in grams per mole. Okay, so the standard amount of gas is going to be measured in moles, and in our formula, PIVNERT, the ideal gas law formula, PV equals nRT. Okay, so if the question gives you the amount in grams, make sure you convert it into moles first using your molar mass formula. Now, if we go through again, identifying our variables, P is pressure, needs to be in kilopascals. V is volume, needs to be in liters. T is temperature, which needs to be in kelvins. And N again is our moles. Now, there's one other number in that formula. That is R. R is known as the universal gas constant, okay? The numerical value for it is 8.314. And it has some funny looking units because if I were to rearrange this formula and solve for R, I would divide both sides by N and T. Right? So if I were to solve for R, I would have a number from the pressure, which would be in kilopascals, a number from the volume, which would be in liters, over moles, and then temperature, kelvins. So that's what those units are for R. Kilopascal liters over mole Kelvin, okay? Now, I tell my students they don't have to put units in their calculation, but it's very good practice and helpful to do it for unit analysis purposes, which I will show in these examples. But essentially, the key thing is the number for R, 8.314. Okay, so R is a constant, it's a number, 8.314. So let's look at some examples of using this formula. What is the volume when you have 10.8 moles? So that's my N, 10.8 mol, at 100 kPa, so that's my pressure, and 15.5 degrees Celsius. Now remember, I have to convert that into kelvins, so we add 273.15 to convert it from degrees Celsius to Kelvin. So that gives us 288.65 Kelvin. Okay? So notice again, this, in order to again determine which formula you're going to use, this question has amount. It has moles, okay? Which means the only formula that has that is PIVNERT. PV equals nRT. I'm solving for V, so I divide both sides by P. My P cancels. So I'm left with my volume equals my moles, which was 10.8. I'm going to put my units in a different color, just to show you, again, the unit analysis. Okay, so my moles was 10.8. My R was 8.314. That's the constant. And my temperature is 288.65 Kelvin. And then I'm going to divide that by my pressure, which is 100.00 kilopascals. Okay, I'm going to put my units, like I said, in a different color. So I had 10.8 moles. The units of R are kilopascal liters over mole Kelvin. My temperature was Kelvin, and my pressure was kilopascals. Okay? So if you're doing unit analysis, which like I said, I don't force my students to do in Chem 20, but if they're going to be continuing chemistry, I highly recommend they do it. You'll see how the units cancel. I have a mole on the top and a mole on the bottom, so they cancel. I have a kilopascal on the top and a kilopascal on the bottom, so they cancel. Same with the kelvins. Kelvin on top, Kelvin on bottom, so they cancel. So we are left with a liter on the top, and again, whatever unit we're solving for should always be left on the top. Okay, so if I'm solving for volume, that means I should have liters on the top. So 10.8 times 8.314 times 288.65 divided by 100 gives me an answer of 259.18 so on liters. Now, how many significant digits can we keep? There's 3, 3, 5. The lowest is 3. That doesn't cut off my decimal. I'm also not cutting off a 5 or more, so it just stays as 259 liters. That is our volume. Okay? Looking at another example. You have a rigid steel vessel that has a volume of 20 liters at a pressure of 20,000 kilopascals. That's a really high pressure. 20,000 kilopascals. And a temperature of 27 degrees Celsius, which we need to add 273.15 to convert into Kelvin. It should be 300.15 Kelvin. Okay? We are looking for the number of moles of this gas, nitrogen. So N. I am looking for N. So again, that is a hint to me that I need to use my ideal gas law formula, PVNRT, PV equals nRT, and I am solving for N. So I'm going to divide both sides by R times T. Okay, so N equals PV over RT. So my P, 20,000. I'm going to do my units in a different color again. My volume, 20 liters, divided by, now I have two numbers on the bottom, so I need to make sure I'm putting those all in brackets, and I can have multiple brackets if that's what you like to do. So our R is 8.314, and I'll put its units there, times temperature, 300.15, and I'll put its units there. Okay, then I need to close that overall bracket on the bottom. So I have 20,000 kilopascals, 20 liters, 8.314 kilopascal liters over mole Kelvin, and this is Kelvin. Now, if you ever in the denominator of a fraction have another denominator, mathematically it moves up and becomes part of the numerator. So this mole times Kelvin from the bottom moves up to the top. Okay, for unit analysis. So my kilopascals cancel, my liters cancel, my kelvins cancel, and we are left with MOL on the top. Okay, so in your calculator, make sure you use the brackets the way I have here. So you have 20,000 times 20 divided by, in brackets, 8.314 times 300.15. Make sure the whole bottom is in brackets. You should get an answer of 160.29 so on moles. Again, it looks like we can have 3 sig digs based on the question. The lowest of all those digits is 3. I'm not cutting off the decimal. I'm not cutting off a 5 or more. So my answer stays at 160 mole. That is our N. Okay? Next example. What is the pressure? I'm going to go back to using red here. What is the pressure exerted by 15.5 G? That is not moles. That is a mass. 15.5 grams. Okay? Anytime you have a question where you're given a mass, right away you need to think to yourself, I need to convert that into moles. So I need to take my mass and divide by my molar mass. Okay? What is my molar mass? Molar mass, remember, comes by taking the formula of your compound, adding up the elements and the number of elements that you have in that compound. So I'm going to write my molar mass here. I have 1 carbon. Carbon is 12.01. And I'm adding that to 4 hydrogens, which are 1.01. So in total, 12.01 plus 4 1.01s. That gives me 16.05 grams per mole. Okay? I am told it's taking up a volume of 10 liters, and my temperature, again, needs to be in kelvins. 25 degrees Celsius is the SATP temperature, which is 298.15 kelvins. Okay, so I'm going to start by converting my mass into moles. So I take my 15.5 grams and divide by my 16.05 grams per mole. Look how I have a denominator in the denominator again. So it moves up here to the numerator. Okay? So my grams cancel and we're left with moles on the top. Now when I get this answer, it's going to be a big long answer. We are not rounding it. You only ever round your final answer. Now, do I need to write the entire thing on paper? No, I can write it 4 or 5 digits, put dot, 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 meaning this is a big long number. I am not rounding it, okay? Because I need to put it into my Pivnert formula. This is the ideal gas law question. I have the amount of a gas. Whenever you have the amount of a gas, you always are using Pivnert. Now I'm solving for pressure, so I need to divide both sides by volume. So my pressure is going to equal the moles I just calculated, unrounded, so use that entire number from your calculator. I have 8.314 for my R, which units are kilopascal liters over mole Kelvin. My temperature is 298.15 Kelvin, and my volume on the bottom is 10.0 liters. So if we do our unit analysis, moles cancel, kelvins cancel, and liters cancel. So we're going to get left with an answer in kilopascals for pressure. So again, take that answer that you got in step 1, finding moles, unrounded, multiply it by 8.314 times 298.15, and then divide that answer by 10. We get an answer of 239.38 so on kilopascals. Now it looks like, we can only keep 2 digits. There's 3, 3, and 2. So that means I am cutting off my decimal. So I do have to put it into scientific notation. I'm also cutting off a 9, so it's going to round the last digit I'm allowed to keep up to 4. So it's 2.4 times 10 to the power of 12 kilopascals. Our proper answer to proper sig digs. Okay? I'm not sure if there's another question. There's one more question. What mass of hydrogen gas? What mass of hydrogen gas? We want to find mass. Now, in order to find mass, I need to know moles, and then I multiply it by molar mass. Okay? Molar mass is something we can always find. I have hydrogen gas. Hydrogen gas, whenever you have the name of a substance, you want to write the formula for it. Hydrogen is H2. It's diatomic when it's by itself. So my molar mass is 1.01, 2.02 grams per mole. Okay? I also have a volume of 4.5 liters. I have a temperature of -25. So if I add 273.15 to that, I get a temperature of 248.15 Kelvin, and my pressure 102.0 kPa. Okay, so I am looking for M, but in order to find M, I need to know my N first. That's going to come from my Pivnert formula, right? That's the only gas formula I have that has moles in it. I'm going to solve for moles. So we're going to divide both sides by R and T. Okay, so our moles equals our pressure, 102.0 kilopascals, times our volume, 4.5 liters, divided by, again, I have two numbers in my division, so I need a big bracket around my other number. So 8.314 kilopascal liter over mole Kelvin, puts the mole Kelvin at the top. And then I need to multiply that by my temperature, 248.15 Kelvin, and close the first bracket I opened. Okay, so if you use brackets, use them exactly like I did up there. 102 times 4.5 divided by, in brackets, 8.314 times 248.15. We get an answer of N equals 0.2224, so on moles. Let's check our units, but our kilopascals cancel, our liters cancel, our kelvins cancel. We are in fact left with moles on top. Again, I am not rounding this answer. I'm using it as a big, long, unrounded answer, and I'm going to multiply it by the molar mass we found before. So our molar mass, we said, was 2.02 grams per mole. So my moles cancel, and we are left with grams. So in my calculator, that big unrounded mole value times 2.02 gives us an answer of 0.4494, so on grams. Now, sig digs, there's 2, 2, 4. The lowest is 2. Remember, leading zeros don't count. So these are the 2 digits we're keeping. We're cutting off a 9, so it is going to round that last digit we keep up. So it's going to be 0.45 grams. Okay? And that is it for the ideal gas law. Thank you for watching this video.